In this tutorial, we are going to create a simulation for a dough mixing appliance using SimLab Composer. Let's quickly break down the mechanism of the mixer. This horizontal is driven by a motor, which will make it rotate around its axis since it is held by the fixed metal arm. This gear is connected to the motor rod and will rotate along with it. The pin has a ball joint connecting it to the gear, which would give it the freedom to rotate in all directions, while the other side of the pin is connected to a vertical shaft through a cylindrical socket that is also stabilized by the fixed metal arm. And this vertical rod is connected to the arm of the mixer, which in turn will move according to the vertical rod in a swaying motion. The bowl is connected to a motor at the bottom, which will rotate it on its axis. Go to the Workbench's icon in SimLab Composer and select the Simulation workbench. The first step in creating a simulation is converting your 3D design to solid parts that can be physically simulated. To do so, you can either manually select the parts and convert them to solid, or you can click on Auto Detect Solids, and SimLab Composer will automatically detect the objects in your scene and convert them to solids. Once you're through with this step, click on End Solid Creation to proceed to adding joints. Go to the Simulation menu and select Parameters. Set the gravity value in this example to 0, since it will not be needed. Select the arm that is holding all the components and from the Properties panel, click on the lock icon to set it to a fixed solid. Do the same for the base part of the bowl. Setting a solid state to fixed means that this solid will not be affected by any forces or movements by other components. Go to the Links menu where you can create different types of joints and forces and click on Revolute Joint. Adding a joint is connecting two solids together and applying a pattern of movement according to the type of joint created. For this revolute joint that we created, set solid 1 to be the ground, which is translated to having an external force affecting the horizontal rod, and in this case, it's the motor driving the rod. Set solid 2 to be the rod, and then click on one of the rod's curvatures to denote the axis of motion for the joint. From the Joint Attributes panel, click on Enable Motor, and set the speed of the motor's rotation. Go to the Simulation menu and click Start to play the simulation. To connect the rotating part of the mixer to the horizontal pin, we need to use a spherical joint. From the Links menu, select Spherical Joint, then set solid 1 to be the revolving gear and solid 2 to be the pin. Then set the axis of rotation for this joint. If you play the simulation, you will notice the pin is swirling out of its position since the other end of the pin is not connected yet. To connect the pin to the vertical rod, we are going to use a cylindrical joint. The cylindrical joint allows for the movement to be linear in a single direction, but retains the ability for the solid to rotate around its own axis, which is exactly what we need for this connection. Set solid 1 to be the pin, and solid 2 to be the vertical rod. Then determine the axis of this connection by selecting a curve where the two solids connect. The same steps apply for the next joint. We need another cylindrical joint to connect the vertical shaft to the fixed arm holding all the components. Click Start to play the simulation. The last connection you need to create is between the motor and the bowl. Create a revolute joint and set solid 1 to be the motor and solid 2 to be the bowl. Click on Enable Motor and set the speed of the motor's rotation. An additional feature the SimLab Composer's simulation offers is creating an analysis diagram for the simulation. From the Plots panel, select Manage Curves. Click on the Add Channel icon, and then select the solid of which its data needs to be analyzed. Select which property you need to display for the solid. You can either select one attribute to display in the diagram, or you can display multiple attributes for the same solid at once. Click OK and play the simulation. SimLab Composer's ability to produce numerical data and graphs for the simulation is a great feature that allows the user to better understand the simulation. This enables him to easily modify the design to serve the purposes of which it's intended for in a manner which is physically accurate. Go to the Simulation menu and click on To Animation. Set the number of frames per second to display in the animation and click OK. Go to the Animation workbench and play the animation. The physical simulation has been converted to a frame-by-frame animation, which allows you to export or share your simulation as a 3D PDF or a WebGL, or create a 3D rendered video for the simulation. SimLab Composer's Simulation Workbench is a powerful and easy-to-use feature where you can bring your 3D design to life and be able to study and analyze the interaction between the components of your design in a simple and efficient manner.